Hello, how are you, Adam?
I'm doing all right, Ron. How are you?
Not bad. What's new with you this year?
Same old, just
Yeah.
busier.
Yep. Sounds good. So you got a project there for your class.
Well,
That-
so
that- Go
the
ahead.
way it's worked in the past is it's an online class. We've run it twice. It's for teachers, and it's basically a science content class. And the main element, then the main reason why I think I'm going to switch to Google Plus is that I have them do weekly observations outside, and they're supposed to be noticing environmental things, but also, changes to the flora and fauna and that sort of thing. And we used a blog part of our academic software before, and that was okay, but I felt like the blogs were too buried, and that the information, the sort of flow from week to week was too choppy. So that they'd make an observation, take pictures, somebody would comment on it, and then that was sort of cordoned off from their next observation without any amount of flow. And so that's the main reason. And then the capability of trying to have some online meetings, like this.
This is
something
where
similar,
this really shines.
and sharing interesting websites and interesting tidbits,
Yep.
rather than having to do it. So the way we originally did it was through the online blog, an online wiki, and through Twitter. And if I can sort of do all those in one, which I feel like I can do here.
This does a pretty good job of wrapping all those things up.
Right.
Certainly I think you've got all the functionality of Twitter Plus, so I don't think there's really any reason that you would choose Twitter over Google Plus, other than just, some people are going to be more familiar with it.
Right.
The video hangout like this is really your only option on a, free large-scale hangouts, up to 10 people, 9 plus yourself.
Okay.
So that is one limitation, but I don't think, it's a limitation only in as much as if you're trying to get a whole class of 30 students together at one time.
Right.
It can be a limitation. And actually, one way around that is to rotate the students through that. So, they come on for 5 minutes, they ask questions and stuff, and then they move on and let somebody else come in.
Right.
And the other nice thing about this is it's coming in the official version, but it's still very limited. But I'm doing this independently, is to record these sessions. And then you can basically, what I'm doing is basically I'm capturing this with Camtasia.
Yep.
Over on a second computer, so there's actually a third silent partner here, which is a second account of mine that's just completely muted. And essentially, Camtasia catches that, and then after that's all captured, when we're all done, I'll convert that to an MP4 and then upload that to YouTube. And you can edit it certainly if you wanted to.
Right.
But that's basically the idea there. So that's actually useful for archiving for people who miss these things or can't do it simultaneously.
Right. And when you have a large number, how do you find does the bandwidth become a problem?
It works pretty well. There's actually a useful feature here that if you've got somebody who's really bandwidth challenged, you can actually, using the Google Hangouts with extras, through Google Voice, connect to them by phone.
Okay.
So, I have family hangouts every weekend, and one of my sisters has a very weak internet connection.
Okay.
And so we've actually just recently included her via phone. And so she's just calling, she's not actually calling in, I'm calling out to her, but it rings her phone like a regular phone call. And obviously she doesn't have the video, but she can participate in the conversation, and it definitely gets around the bandwidth issue.
Okay. And you just froze up there for a minute. How has that been with the chat?
Well, you know, by and large, pretty good. Certainly for a free product.
Yeah.
You know, there's a little bit of lag too. You sometimes get echo. You know, there are various things like that. It's not going to be completely flawless, which means that if you're, you know, if your students have expectations that it's going to be completely flawless, well, they're going to be disappointed.
Right, right.
But, you know, as long as they're willing to work with this and, you know, give them a caution ahead of time, it actually works pretty well.
Okay.
And, you know, if there are problems, you can always have them log out, come back in. Sometimes that solves things. Elaine, welcome.
Hi.
We're just chatting about a class that Adam's putting together that's going to possibly use Google Plus and Hangouts. So feel free to contribute there. And, but I know that Adam had a relatively short time window to participate here, so I'm going to give him my attention right off the bat.
So Ron, how have you been using this?
These Geology Office Hours Hangouts, like you're seeing here, I've been doing this every Monday and Thursday. I took a 2-week break here over Christmas, New Year's. But basically, they're open-ended. They're open to the public. Once they started putting in the controls where you can block people, that became tenable again. Originally, when they didn't have the moderation controls, I had a bunch of good sessions, and then we started getting trolls coming in and just disrupting. So I had to go to private sharing at that point. But, you know, it's basically whoever shows up. And some days we have a full house, and more often it's about 3 or 4 people like this.
Okay.
Some days it's just, you know, dead. I've tried to do the regular scheduling so that people kind of know when to come back. You know, you could certainly do ad hoc scheduling, you know, if you felt the need for it.
Right.
And you can see there on the left-hand side, you see the chat.
Mm-hmm.
And you see we got Michael McLaughlin trying to get on and coming in, coming out. He's probably got connectivity issues.
Okay.
So to your earlier question about that, yeah, there are definitely some issues there, and you know, people have to get to know how to use the webcam and the mic. They can participate just via the chat over there.
Okay.
But it definitely loses something from the overall experience. Anyway, I mean, my goal here has been basically to answer questions, just like I would in an office hours.
Right.
I usually don't have a lot of structure. It sometimes works better if I seed a topic, but you know, I'm really kind of here to answer questions, and so I don't have any particular goals beyond that. And you know, it's building up a certain amount of community. There are some people who show up fairly regularly, at least on certain days of the week. It's been, you know, 2 weeks since I've had one of these, so it'll be a little thinner today. And then just random people that show up. And, you know, because I make it a public announcement, so anybody who's following me or anybody who's searching on geology will see this.
Right.
And, you know, this is intended really to be kind of that ask a geologist sort of thing.
Right.
As much for me to test the technology as anything else initially, but it's, you know, it's got a nice group that has come together, and there seems to be interest for it.
Yeah.
I don't know if it would sustain more than twice a week. As it is, I'm contemplating just going to once a week.
Okay.
You know, It's good. We haven't had a really big geologic event in the news. It's always been my thought that if we did have something big, especially in the U.S. or something that was, global but of, particular geologic importance, that I might have a few ad hoc hangouts to address that.
Sure.
But we haven't really had one that I felt strongly we needed to do that.
Okay. So. Have you used the notes or the sketchpad features or any of that stuff?
I've given them brief attempt. Yeah, I tried them out when I first started. With a mouse, the sketchpad is not great. I think probably if I used a Wacom tablet or something like that, that would probably be a lot more useful. But you can sketch basic things. What I really like about the Hangouts with Extras, which is what we're doing here, is the ability to share screens.
Okay.
So you see that button on the top there. And actually the capture moment is a relatively recent thing. So if you just want to catch a frame, the capture moment basically just takes a snapshot of the screen. Okay. But one of the big things here on the sharing screens is, for example, I was doing something earlier with Google Earth, Gigapan and Google Earth. So now you're looking at a screen there of my Google Earth window, which I have to say on my own screen is flashing in such a way that it would give me a seizure if I were prone to them. But for your view, it looks good. And then if I wanted to then zoom in on this one, let's see if I can do this. And I'm going to zoom in on the original. So now you're not going to see the smooth scrolling that I'm seeing, relatively smooth scrolling, but every time it stops, it'll refresh the image.
Right.
So as I'm zooming in on Mount Moran here, you can see the Mayfic dike on the top of Mount Moran, and my mouse cursor there should slowly catch up and show that I'm highlighting the dike there.
Right.
And oh look, the Cambrian Flathead Sandstone up top there too. So you can begin to see how that would be useful for sharing, geologic information to a group. I'm going to stop sharing that for now. And eventually I should come back. And yeah, it's a little laggy. It's not perfect, but it certainly is a good solution for the price.
Right.
There's nothing else that does this in this way. I actually did try and do once when I was still teaching at Fort Hays. I did some review sessions for exams. This is before Google Plus existed. And what I used there was my smartphone and the, what is it? Yeah, I'm drawing a blank on the name of it right now. But for sharing video publicly, what's the name of the product?
Vimeo or?
Not Vimeo for live sharing.
Oh.
I'm just having a brain freeze. But anyway, I shared that as live video. There you've got a situation where it had advertisements, a pre-roll ad for 30 seconds before you even start to see the video. It had a chat interface, but you had to be logged in there to use the chat interface, which meant everybody, so you could see it publicly. I could embed it on a website publicly, but the chat was separate from that, and so it was not as good an experience as this. Now, frankly, I can't embed this on a website for live viewing, so it's, 6 of one, half dozen the other. They're different experiences. I imagine eventually Google will enable that sort of thing, or, may potentially enable that sort of thing.
Okay.
But, that's useful. So I did that with review sessions for students that could. So I would have the review session in the evening for an exam the next day. I had some students that commuted to campus and couldn't really get back for an evening review session.
Yeah.
But they were able to watch a review session online in real time from the comfort of their own home and text in questions. And I used kind of Twitter as a secondary thing for that. This is a better interface, I would say, for that. The main limitation is that you go only up to 10 participants. And they're working on a way around that, but that's basically something they've only rolled out to a very select few people. Okay. So there would be basically the idea of having a public hangout where you have a limited group of people that are actually participating in, dynamic conversation, but then everybody else could watch it via a live stream.
Gotcha.
There are a few of those that I've watched, and I don't remember whether you had access to the text chat if you were just viewing it. I think you were just able to view it, strictly that.
Okay.
It's evolving. That's the other great thing about Google is, if it doesn't have the feature yet, it may be before the end of the semester.
Right.
Not that you want to depend on that, but
yeah. No, and we used to use I didn't really use the first year very much, and then I used it more last year, and then I was recommended by people to use even more discussion to try to sort of wrap in these online students.
Yeah.
We've used Adobe Connect.
Yeah.
And
I've heard of it. I haven't actually used it.
Yeah, and so we have a a license or rights to it or whatever on campus, and generally it's worked beautifully, but more and more lately it seems maybe the issue's not on our end, but when I try to invite people to take part in it, inevitably, like Skype or anything else, you run into connection issues or freezing or whatever, and so again, just the fact that that's one more piece of software that they need to, you can get it through the internet, but one more thing that they need to interface with and sign on to and that sort of stuff. And the one benefit of that is you can run PowerPoints, you can run notes and chats and all that stuff there. But again, if I can have one overarching interface that they're going to use.
Yeah, well, of course, you can run a PowerPoint here. All you got to do is share your screen with PowerPoint.
Right.
So you can talk over it and run through it as you go.
Right.
That really would work fine, I imagine. In fact, you can switch, from one application to another. You want to go PowerPoint for a while and then jump into Google Earth.
Right.
That would be a spectacular use of that. So the sharing screen is definitely a killer feature among the features here.
Okay.
I think you're going to run into some of the same issues. If students are having bandwidth issues, that clearly can affect this. It's pretty tolerant of low bandwidth connections, but you're going to run into some people that are just unable to get through. Okay. It's free, but you don't have the kind of support resources that maybe Adobe has. I don't know if you would have had access to those support resources, but certainly somebody who was paying at the university would have had some support. I mean, there's a lot of people using this, and so just chatting with me is it's crowdsourced support.
Right. Well, and if you keep having these sessions, I might have my students check in with you on some of their. I mean, that's part of the idea is that I know some things, but I don't know everything, and I'd rather them learn from multiple people than just from me.
Yeah.
So
I like the idea. I mean, right now, my employment situation is such that I don't know what my schedule is going to be all year. Right. So I can't make any long-term commitments on this, but I'll certainly do my best, and certainly if you're going to do something evenings or weekends, I ought to be able to participate and help out.
Do you know of anyone else, particularly, I have background in geology. I have no real background in biology whatsoever, and some of the content we cover is definitely more bio-focused. Do you know if other people are doing similar open hangouts or open office hours?
I have to say, I don't know off the top of my head, but I would suggest two things. One, you could do a search in Google+. I don't know. Well, just search Biology Office Hours Google+. See what you get.
Okay.
you might get something. This office hours concept has kind of caught on, so you'll find people labeling things office hours.
Okay.
I can't claim that I was necessarily the first, but I was doing it pretty early on. The other thing is you might contact some of the Google Plus folks who are kind of facilitators for Google Plus Hangouts. Catherine Graham, let me see if I can find her handle here. How am I going to search this?
I lost your last minute or so of discussion there.
Okay, I'll try and get it up here in a minute. Here, just like let me find her handle. Yeah. So, oh, that's not what I wanted to do. Come on. Let me drop this in the text area there. So there's that's her Google Plus post page. She's one of the community managers for Google Plus Hangouts. So you might just shoot her a I don't know, a Google Plus a comment in there, make a post to her, and ask if she's aware of anything. I don't know any of the other people who are specifically that way. I stumbled upon her, and so I know that she's one of these community managers. I assume there are a couple. As far as biology goes, myself, I'm doing my best to keep very focused on geology as far as the sciences go. This is just a choice that I made personally. So I have not tried to follow a lot of these people who do a lot of just science blogging or general science blogging. I'm trying to keep really focused into geology. So, I mean, I do follow a bunch of those folks, but I don't follow them very closely.
Sure.
So I don't know and probably with biology, there's a lot of people out there. I mean, I would imagine it's almost an order of magnitude more than geologists.
Right.
And so I would bet you could pick your subspecialty and go looking for somebody.
That would be nice.
Yeah. I have to say, though, my experience with geologists suggests that although they're willing to get onto Google Plus, and some of them will make the effort to get on and use the Hangouts, it's surprising how many of these folks who are good at blogging, use Twitter a lot, cannot coordinate themselves enough to get a camera with a webcam and a headset hooked up to a computer. I'm overstating that a little bit, but when you say, hey, this is a perfect conversation for a hangout, it's like there's a wall all of a sudden. Right. There are certain conversations that, they work okay on Twitter, but they'd really be better suited to a genuine discussion here in a hangout. And I know I've tried to throw that suggestion into one of those discussions, and it just killed the discussion. So it's a problem that will take a little time for people to overcome. I mean, a lot of people have laptops with built-in webcams.
Yeah.
They're just not, willing to. It's like programming the VCR, I guess.
Right. Right. All right. Well, thank you very much. I hear that
my pleasure, and feel free to ping me again. I was taking a break over the holidays. I'm usually a little bit better about getting back to you, but I'm not making guarantees.
No, it's understandable. Thank you. Thanks for the information, and I'll definitely be in touch.
Yeah. Monday and Thursday at 4 p.m. Central is when I'm holding these hangouts. So if you just want to shoot a question to me that way, feel free to drop in anytime.
Okay.
Sounds good.
Great. Thanks, Ron.
Nice talking to you.
Bye-bye.
Now, Elaine, you have my full attention.
It's my first hangout, so I'm just listening.
Am I pronouncing your name all right?
It's
What's the proper pronunciation? Huh?
Alain.
Alain. All right. I'll try and
it's
remember
French.
that. I won't be great. Well, I can say Alan easily enough.
Exactly.
Good enough. All right. I just was trying to go off the spelling and.
Yeah.
So, what brings you this way?
Actually, I follow your Google Plus account.
Okay.
I'm, let's say, aspirant to this science side of mine. Let's put it this way.
I have to say that on Twitter, for example, I a very strong effort to not follow back everybody that follows me, but at least keep up with the people that are following me if they seem to have similar interests. With Google Plus, I just occasionally get swamped with new followers, and I have yet to find an efficient way to go back through that whole list and actually sort through them. So don't be offended if I'm not following you back.
No, not at all. No. But this
is
not
my
no,
it's really odd because I mean I follow almost like 1,000 people on Twitter, and you know a little over 1,000 follow me back. But on Google Plus here, I had initially built out about 400 people or so, 300, 400 people, and then when sharing of circles took off. And also, there's another website that actually has me as a suggested user, not the official Google one, but some other unofficial site. You know, I just get this constant stream of people following, and I've just ceased to try and keep up with it. So
don't worry. I love to read the posts, and that's my objective, to know more and to these little pieces of the world. It's nice.
So I'm going to guess from your accent. Are you French?
Yes.
Okay.
Yes and no. Actually, a bit more complicated than
okay,
that.
Go ahead. Well, I mean, if you're willing to share.
I was born in Brazil.
Oh, okay.
From a Swiss mother and a French father.
Okay. Well, at least I detected some French in there.
Yeah, that was right. And now I live in Austria.
Okay, so it's a little bit late for you. That was my guess. I was going to guess at least that you were in Europe somewhere, and so you're up late at night.
It's pretty dark outside.
Yeah.
And yeah.
So you're interested in geology. How does that come about?
Well, let's say I had a
you're surrounded by great geology. I should say that.
That's I'm a landscape lover. I love landscapes, and I had a very inspiring teacher at school. Okay. My geography teacher, but we had a lot of field work because I had high level on geography. So we had these field works, and it was just awesome. I loved it.
Excellent.
And yeah, it fascinates me. I don't understand much. I mean, I went to a totally different direction. It's business and marketing, so I'm completely not.
That's okay. You probably got income and a job, so
yeah,
that's worthwhile. I have limited experience in alpine geology. I did when I was a graduate student at Wisconsin. Had a field trip for about a week, 2 weeks maybe, to the Swiss and Italian Alps. So I've seen a little bit of that, but that's my only trip to Europe. It was probably at least it's probably working up on 15 years ago, maybe more than that, probably more than that now. So it's been a while, but I have at least seen the Alps up close, and it's a spectacular range, spectacular geology. And although I'm not really qualified to comment much on the specifics of it,
trust me, you're more qualified than I am.
Well,
but it's true. It's beautiful. It's beautiful. Yeah. I'm right now for the next 9 months in Austria, but I live in Switzerland.
Oh, okay.
And but not in the Alps.
Right.
I say area.
Right. What part of the country?
In the we call it the Jura.
Yeah, Jura. Yeah, sure.
The Jura.
Yep.
So
sure.
It's also very interesting, beautiful, but it's not that high and that.
No, but that was definitely it's part of the whole alpine collision. It's lower topography, less mountainous, but there's still great geology there.
Yeah.
In fact, I've just been spending much of my Christmas break searching through gigapans. Are you familiar with gigapans? Have you heard of gigapans ever?
No.
All right, so these are basically really supersized photos. This is something else that I spend a lot of time doing, although you don't see as much me posting about it in Google Plus because there's no easy way to share these gigapans. But gigapan.org is the website. Gigapan from Gigapixel Panorama. So gigapan.org or .com, either one, I'll get you there. And what these are these zoomable pictures. You start with a zoomed out view. And then you can navigate in and zoom in to see fine detail of the pictures. You've certainly used something like Google Earth before, right?
Yeah.
Okay. So you know when you zoom into Google Earth, they get progressively higher resolution as you zoom in. Same concept applied to a photograph.
Okay. Yeah.
And the way you produce these photographs, well, there's different ways of producing it. You can get either a really, really expensive camera with a really huge sensor, or the way most people are doing it these days are with a robot. And I got one around the corner, but it's not going to be easy to get to. But it's basically a little robotic head that you mount on top of the tripod. You put your own digital camera onto this thing, and what it does is it rotates around, and it's got a little button press that presses the shutter of the camera. So you shoot a grid of images.
Wow.
You stitch these together in Photoshop, or they have a software specifically dedicated to this. You upload them to the gigapan.org website, and there you can go and explore them. You can also view them in Google Earth, which is what I was showing before. I don't know if you saw that.
Yeah.
So it's spectacular. The other point of that is I just spent the last 2 or 3 weeks basically going through all 95,000 or so gigapans that are in existence because I'm trying to make a collection of just the geological ones. There's a lot of them shot in the Alps. There's a lot of cityscapes as well, so you might find that interesting as well. But I got a whole lot of alpine ones. Unfortunately, a lot of them by skiers who just have a handheld camera to shoot 5, 6, 7 pictures, stitch them together. It's a very minimal gigapan, and most of them, if they're skiers, it's all snow.
Yeah.
Least interesting, least explorable sort of thing. Although at least it's got little bits of mountain peaks in it. Anyway, so that's a little aside. Anyway, so I've been seeing a little bit more alpine geology, although I haven't really had a chance to dive deep into that yet. That's the next week or so.
Next week, yeah. Excellent, so nice, cool, wow.
Yep. So, any geology questions I can actually answer for you, just in keeping with the actual office hours concept.
Model, yeah. Well, actually, I don't have any. I'll come next time with some.
That's actually one of those things that it's nice to just have a conversation here, and especially when it's just two of us in the room here chatting. Conversation can go just about anywhere, but I do, when I have more people there, I try and keep it on topic with geology. So it looks like Mike is still trying to get in, but it's not having much success. That's neither here nor there, not our problem. But
wow, so, this is very nice. I didn't think it was so nice.
Yeah, so this is the first Hangout you're using?
Yeah, it's the first time I'm
okay.
on this,
well, you got the video and the audio done pretty nicely. I don't seem to see any sort of an echo or anything like that. So
yeah, I put the mic.
Are you hearing any echo from me?
No, not at all.
Okay, because I have had a few situations with some of my family conversations where they've been hearing echo, and I've been trying to fix that, but it's hard for me to judge whether I'm generating it or not.
Yeah, before when you were talking to the sir, there was some echo.
Okay. Yeah, I'm not using a headset just because I'm trying to make it do without. I have one. I could easily pull it out. It's just not as fun. I don't have the earpiece. That would actually be a good thing for me to get as a
it's just a small. but it's true that sometimes it annoys. After some time, it's not that. But it's nice. It's nice.
But,
wow.
Yeah, well, these Hangouts, they work pretty well, and I've gotten a lot out of these. I've been doing it fairly regularly, so I actually have lots of experience with them. But it's definitely hard to draw people into them. So there are now hundreds of geologists on Twitter using it on a fairly regular basis, and I have a group of like 300, but there are maybe 30 or 40 who are using it every day, frequently during the day, and even among those folks, the number of them who have come on and used Google Plus is remarkably limited. There's about a half dozen of them who feel fairly comfortable pretty much in whatever medium you drop them down in. But I'm really surprised that a few of them, some of it's scheduling and not being able to chat. I mean, Twitter is something you can do on your phone when you're traveling or whatever. A hangout like this is definitely a little bit more of a commitment of time and attention.
Yeah.
So that's definitely an issue, but yeah, whatever.
I might have a question actually.
Go ahead.
I was on the train heading here to Austria, and on the way there was this I don't know if we can call it a mountain. It was like a peak in the middle of nowhere. Okay, and now you have to imagine that you have this Swiss plateau in the north, and then you have suddenly this huge piece, almost like a pyramid in the middle of nowhere.
Right.
And then I ask myself, how do you get that? How and how much time do you need?
It's a great question, and I don't know the specific area, which is the problem in trying to answer that. I'm going to have a couple of similar examples in the U.S., but the other thing is I got Google Earth here. It's going to take me a little while to fly over to Switzerland. Actually, I could probably type this in.
Yeah, actually, I'm looking for the picture because I made a picture of it. I was so impressed.
If you do find it, you can probably just share that picture.
Yeah,
using the share your screen. Or share your screen.
I'll put share. Let's see what happens.
Sure.
Google Talk sharing. Okay, desktop. Or okay, yeah, this one. Let's see what happens. So let me see. See if I can get it. Don't mind the pictures.
That's fine. That's fine. It's the internet. These are. This is standard internet fare.
Oh God, this is very okay. This is This is not it.
I'm surfing my Google Earth here anyway, so.
Okay, this is not it. In here somewhere.
Do you know a town nearby, or where you were roughly when you?
Yeah, it's Bregenz. Wait, I'll put it. I'll write it down.
Sure.
It's very nice. It's a very nice formation. Where did I put that? Somewhere.
Okay, so you're near the south end of Lake Constance.
Exactly. Yes.
Yeah. Okay. I'm just beginning to search. I'm in the neighborhood.
In the neighborhood. Yeah, I have a very nice picture, and now I just lost it.
Take your time. Take your time. There's no rush. I'm used to being on for a full hour here, and
I think it's this one, but this one is not a very nice one. I think it's still on my phone.
Okay. Yeah, I'm seeing the general area. No individual peak is really jumping out at me, and so I'm hesitant to guess now. On the other hand, if you're right in
Okay. Where is it?
You know, I actually have a geologic map of Switzerland, but of course it's nowhere near that I can actually look at it. So it's a limited.
Yeah, I have this picture. Just looking. Stop sharing this for you.
Okay, you know, this is off the cuff. It's perfectly all right. Wow. There's some good geology there. I'm just seeing this just in Google Earth. I can see there's good stuff. I don't know. Now there is actually a mountain right in the middle of that valley, but it's small, and I don't know if that's the one you're referring to.
In almost a perfect shape, then that should be it. It's very regular. It's not how you say, like usually very chaotic, where you see the how you say, I don't know if rupture is the right word, where you see where it's separated blocks of massive blocks. But oh, hi.
Adam's back. You're mobile and back.
I didn't mean to interrupt. I just wanted to actually see if my phone.
Yeah.
I was thinking about the potential of doing one of these outside or doing it remotely, and just wanted to see if it would work, and it did. So.
Yeah, resolution isn't as great, but that's your mobile. What sort of phone are you using? Just out of curiosity.
I'm sorry.
What sort of phone are you using?
iPhone 4.
Okay, interesting.
So.
Sounds good.
Okay.
Well, yeah, it looks good. It's working.
Cool. Thank you.
All right.
All right. Take care. Bye.
Good talking to you.
I think I found it.
Okay.
It's still on my phone, and it looks. I don't know if.
Yeah, I can see that, and So it's got the classic pyramidal sort of shape.
Mm-hmm.
You know, okay, so what I can see from that, which is definitely lacking in some detail,
Yeah.
do you remember which direction you were looking at that? Which were you looking toward the north or toward the south?
This is a train rail. Right? Maybe I can find it. Let's see.
Yeah. Okay. I've got an idea what you, or even what time. See, what I'm thinking as a geologist is first of all to get the lighting. So you had pretty good sunlight on that peak.
Mm-hmm.
Normally that suggests to me that you're looking northward, right, in the northern hemisphere because the sun's coming from the south. But
exactly.
if you were in the morning or the afternoon, it could be from the east or the west. But it also doesn't look like you were looking like due south at the mountain.
It's in the morning.
Okay, it's a morning shot, so that could be looking back to the west. You know what? Okay, there's a peak here that kind of looks like the one that you've got, and I'm not going to be able to give you a definitive answer here, but let me see if I can find the name of this peak. There's one named here. Come on, show me.
Yeah, the time, maybe with times.
Ebenalp?
Sorry?
Ebenalp?
Ebenalp.
Ebenalp. Okay, so these guys are actually, the ones that I'm looking at are just to the, well, they're to the southeast, and in the Appenzell inner
Yes.
Is that the right area?
Yes.
Okay. So I think I see the peak, and what it is it looks like it's actually just a little bit out from the main set of peaks, a little bit north of the main set of peaks. So it's not as isolated, perhaps, as I initially thought. But in fact, that was actually the one that caught my eye when I was just flying around. It looks to me, and again, I don't know the area real well, but it looks to me like these are a series of relatively steeply dipping sedimentary layers.
Okay.
Now, they've been folded up as part of this collision. So these were originally flat-lying sedimentary rocks. They get caught up in this continental collision. They've been warped up and folded. I mean, the whole Alps is pretty contorted. But I think what you're seeing there is just a group of relatively unfolded rocks that are just tilted, more or less tilted about 45 degrees or so. And I think what you're seeing is probably one side of that peak is actually like the, what we call the dip slope, the original bedding surface. Oh. And that the other slopes are probably just a kind of, angle of repose, basically as steep as slopes normally get. Oh. So I think it's just your particular perspective on that mountain that made it look very pyramidal. If you look at it in Google Earth, it's actually elongated, and that would be consistent with a series of tilted beds.
Oh, okay.
I think that's the situation. Now, obviously, without a more definite thing. Now, the other thing I could do, and I should try, see if I can find anybody else's pictures by looking at Google Earth here. Oh, there's all kinds of pictures of this. Yeah, not the picture that I want. Yeah, lots of pictures of restaurants. And I want an Alp here. Yeah, I don't know if I'm going to be able. Switzerland, of course, has lots and lots of pictures, so it's not going to be as easy to find a single one that's got the same view or the. Yeah, I'm not going to be able to find something in short order for you there, but that looks to me like the situation. So I think you're just dealing with some tilted sedimentary rocks. You're viewing on end. You're viewing essentially along the length of the beds, and that they are eroded, and so the sharp peak is just a remnant of the erosion. And they wouldn't look so perfectly pyramidal if you weren't looking on them on end. So I think if you came around 90 degrees, you would see a long kind of ridge.
Uh-huh. Yeah. Look, I found this one. It's this one, right? Just a second. Desktop. Chapter.
Yeah, that looks about right. Just south of Appenzell.
Exactly.
Yes. Yeah. I think that's the one that you're referring to. Now, actually, I'm looking for the peak itself. Come on.
Yeah, because the wood show. Yeah, that would be about right, because the train comes exactly through this valley part here, like here. So
yeah, I think that's the location that you're looking at. And yeah, they are beautifully sharp peaks. With a little bit more searching, I could probably find some better some views to match yours. But actually, if you get a chance, if you can share it from your phone in Google Plus, not today. Doesn't have to be today, but just
I can improve this.
Whatever. If it's a problem, don't worry about it. I was just going to say, if you want to try sharing it, you could always just share it, and I could look it up later.
But so how does something like that happen? I mean, what I learned at school was you have two plates, and then they collide, and one gets over the other one, and then you have a mountain. Or
It in its simplest form, that's exactly what you're looking at. You're looking at a big collision there. Northern Italy is essentially the leading edge of the African plate. Okay, and southern, or I guess northern Switzerland, was the southern edge of the European plate. There used to be an ocean in between there, and for a while the ocean was subducting beneath. I'm not remembering which way it was subducting, but it was subducting in one direction or the other. And eventually the collision is when those two continental plates come colliding with each other, and that's what drives up the Alps. It's a classic continental collision. It's one of the examples we cite all the time in intro geology classes. What you're seeing in the individual mountain ranges there is little fragments of that collision. So these layers in the Appenzell region there, those were probably layers that were a whole series of carbonate reefs, sandstones, things that were deposited in the offshore region while that ocean was still there. All right, in a big stack of flat-lying rocks, big, layer cake sort of stratigraphy. And then when the collision happened, these things got tilted up on end as part of that whole collision. And then erosion has then sculpted them into the mountains that you're seeing today.
So actually those how can I say, structures are actually the beginning, the feet of the whole collision.
Yeah. And what you're seeing is just kind of an outlier of the main collisional belt, but it's part of the overall collision. Which, I mean, really, the Jura is part of that collision as well. The valley in between the Jura and the main Alps is basically a region of rocks that were relatively weak, and so they got eroded down. And so they're part of the collision as well. They're just not as resistant. And the rocks in the Alps proper are, well, A, they're still uplifting, but B, also they're probably more resistant rocks. So it's a combination of the collision, but also the erosion subsequently that's wearing this material away. And some rocks are more resistant to erosion. They stand up as mountain peaks. Other rocks are more susceptible to erosion. They get eroded down as valleys.
Of course, yeah.
Okay. I could probably give you a more specific explanation for these particular rocks if I knew more about their age and their, specific rock types. But that's a nutshell overview of that whole thing.
Okay.
Michael, I'm glad you made it here. I just wanted to finish up that explanation for Alan. It looks like you're on and stable for now, so.
Yeah, did you see me attempting to log in for half an hour? I don't know. I'm not sure what was wrong. I tried different browsers. Anyway, I'm here.
I thought maybe it was just a bad bandwidth connection or something like that.
I don't think so. Anyway, yeah.
Well,
yeah, I wanted to ask you a question on something I came across from the Google Plus streams, but I wanted to make sure that Alan got his questions answered first.
Thank you. Well, go ahead.
Hi from Denver. So the first thing I want you to know, Ron, is that I went ahead and got this.
Excellent.
And I started it last night, so it just arrived. So thank you for this. I'm still in the 25 to 50 million years after the Earth's formation phase. Yeah. So we're still in a molten phase.
Yep.
So just want to let you know that. But then someone had posted something on the Google Plus stream that captured my imagination a little bit. And it was an episode from the West Wing about bias in our mapping. And the episode had to do with showing a map upside down and other things. And can I share my screen for a second?
Sure, go ahead.
To see something. See if you can see this. Let me see if this works.
Yep.
Okay, good. So this is just an upside down representation of the planet.
Well, it's right side up if you're Australian.
Sorry, thank you. It's right. South is to the top.
Yep. I've seen maps like this. Yep.
And one thing I noticed is, and I see this all the time, but you see it so often you don't even think about it. And this could be, I should preface this by saying that this could be a visual bias on my part, a viewer, and it has nothing to do with reality because I don't have any statistics or anything. But you notice the shape of Africa, in this case, is now, the continent is pointing up, as is South America, as is India.
Mm-hmm.
As is Tasmania here on the very southern tip, and perhaps Mexico, and maybe Kamchatka and a few other areas. Is this my visual bias, or is there some geographic or geologic reasoning why we might have some of these continents that are pointy and they're pointing in the same direction?
Well, I have to say, first of all, the projection of this map is not entirely responsible for what you're seeing, but maybe partially responsible for what you're seeing. A globe would be a better thing to compare the shapes of the continents on, just because there's no projection bias in a globe.
Yeah, that's true.
But nonetheless, I mean, you point out accurately that there's a pointed area of India that's pointing to the south. There's a pointed area of South America that's pointing to the south. There's Africa, I would say, less pointed, but yeah, you could argue that there's something pointing to the south there. Certainly part of this has to do with how the continents broke up when Pangaea broke up. So the last large supercontinent 250 million years ago was Pangaea. Basically all the modern continental land masses were part of that Pangaea supercontinent. And India and Africa, Australia, Antarctica, and South America were really all together as part of Gondwana land, which is really one portion of Pangaea. It's the southern half, essentially, of Pangaea. And when that split apart, and it split for a wide range of time, it didn't split all at once. But when it did split, you basically got the modern shapes of the continents. Also, you should remember that the true shape of the continent is not necessarily what's above water, but what goes out to the continental shelf edge.
Right. So
really a better representation of the shapes of the continents would include the continental shelves.
Sorry, that's my dog.
That's fine. He's welcome to participate. I just won't be able to answer his questions. Anyway,
participate.
Yeah.
So no, I follow the continental. I mean, if we were to look at a map that showed the continent, showed the entire continent, including the submerged section, would they still have a similar shape? And it's just
it wouldn't change dramatically. It's not going to change. Well, I should say, for the most part, the general point that you were making earlier about the general pointedness shape, that's not going to change dramatically. Although South America, there is a portion in the offshore region that makes that a lot less pronounced of a point.
True.
So I would say, there's some reason that, the continental shelves would factor in there, but there's nothing geological per se in the pointedness shape of that, except that when continents break up, if you have just a large landmass and it begins to break up, what you tend to get is three joints, and I don't have a third hand to do this, but all at 120-degree angles to each other. All right, so you tend to get a split that gives you 120-degree angle here, another 120-degree angle up here, 120-degree angle over here. So you get three blocks breaking apart. If you've seen mud cracks, they tend to do about the same sort of thing. This is just a geometric orientation that's very common in nature. It has to do with symmetry and things like that. If you look at the, let me take my Google Earth here to a point where I can show you this nicely. I gotta fly around a bit here. Google Earth, of course, is a good way of looking at this because Google Earth is a globe. It's not a projection, or at least it's not much of a projection. All right, let me share my screen here for a second. Are you seeing Africa there?
Yes, thank you.
It's flipped over in my view. Are you seeing it in the correct orientation?
I'm seeing it in the usual orientation. Sahara,
all right.
Sahara to the top.
Yep. Okay. So South America, that eastern tip of South America, fits very nicely, as you'll remember from grade school, cutting out the continent shapes. Fits very nicely into this west coast of Central and Southern Africa, right? Well, that 120-degree angle that I was talking about a minute ago is really reflected right there, right, in this projection. I don't know if you're seeing that. Are you seeing that?
I'm seeing Google Earth, but I'm not visualizing it.
Okay, so my cursor is, you're not seeing my cursor as I drag it along.
Is it near Senegal?
Yeah, what I'm trying to point out is just that bend in the coastline, the
coast. Okay.
of Africa there, Cameroon.
Yep.
That is basically one of these bends, and there was a third failed rift arm that goes back up through Cameroon. All right, Mount Cameroon volcano is actually part of this failed rift arm. All right, that was originally trying to break apart. If I go to the other side of Africa, you can see this even more dramatically. If you look over here at the Arabian Peninsula and the Horn of Africa, all right, the Red Sea, the Gulf of Aden, that forms almost not perfect, but it's about the 120-degree angle. And the third branch of that is the East African Rift Zone that continues down here into, East Central Africa.
The Great Rift Valley.
And right now, the Red Sea is a very young ocean basin, as is the Gulf of Aden. And, whether the East African Rift progresses to full oceanhood or not is, it's a hotly debated topic, but it's certainly on its way. But very often you get two successful arms and then one failed arm of rifting. Don't take this too far. Don't, for instance, go up to the Persian Gulf here and try and apply the same thing to the Strait of Hormuz, which does have an angle there, but it's a whole different story geologically. Okay. When India, though, broke off, I mean, the point that you were making about this pointed shape of southern India, when India broke off of all this, you know, the west coast of India here should project down to, I think, the east coast of Madagascar, if I'm not mistaken with my reconstruction. What fits on this west coast, I think, is originally part of Australia. Now, that's so separated now that it's not so obvious, but what you had there was some sort of a two-stage separation where, you know, India went off by itself eventually, but initially it was just like a keystone piece within the Gondwana supercontinent. What I should really do is pull up for you an animation of plate tectonics. Let me see if I can find one of these. There's 2 or 3 good versions of this. I don't know if I don't have them bookmarked, so it's going to take me a minute to look for it. But
it's okay. I've seen it over the years. But you mentioned learning about this in elementary school. I'm afraid I'm a bit older than that. It might have been high school for me.
Sorry, I'm only trying to.
But thank you.
Let me find. Come on.
By the way, I have to boast it's 18 centigrade here right now. 63 Fahrenheit, unusual.
Yeah.
For this time of year.
Oh yeah, that's right. You got the warm air coming up. It's a little cooler here in Kansas, but not quite as. So okay, I'm gonna share this. I don't know how well you're gonna be able to see this because it's kind of small view, but yeah, that's definitely not going to be the ideal size. Are you seeing that reconstruction there?
Yep.
So this is late Cretaceous, 94 million years ago. Here you got North America. The North Atlantic Ocean has been opening at this point for almost 100 million years. So it's a moderately young ocean, but it's still open. South Atlantic Ocean is just beginning to open, so South America is just barely separated from Africa at that point. But I want to really point out India here. India was kind of wedged between Africa and Antarctica. And when it rifted apart, you know, there's kind of this three-way junction. It's not the 120-degree angle that's ideal. All right, it's clearly not that. But that's what you're seeing. It's another one of these triple junctions is what we refer to them in geology as, triple junctions. So this is a kind of failed triple junction where only 2 of the arms continued. The third arm died. But if you look at the South Atlantic here, there's a 1, 2, 3, and that's not so convincing. But certainly here around India, 1, 2, 3 arms, all that were successful. And India is then off on its own, and it's going to begin swinging up north toward there. You know, I don't think, if you look at them, you can begin to see that, well, if you project backwards, South America, Africa, India, Australia, Antarctica were all together during the Pangaea supercontinent. The point at which the breakup begins, you know, is somewhere along the south edge, the South Atlantic. And I don't know how much of the current shape of southern South America is a more recent factor, because the fact is, the Antarctic Peninsula is more recent. And some portions of the southern end of South America are probably more recent in terms of how pointed that looks on a modern globe. That's not the case for India. India is very much just a fragment that's been drifting since this breakup. And for Australia, you know, it kind of fits the Antarctic coastline there. And, you know, I don't know how pointed I would say that was.
So it could be just a function of the gradual movement of continents away from each other. At this point in time, there happens to be some pointiness, but it's random based upon just where the plates are at this moment.
Yeah, I can't think.
And a function of the split.
Specific geologic reason for general pointiness.
Okay.
Right. So individual cases you might be able to come up with. The shape of southern Africa, the southern tip of Africa, is definitely indicated by how it rifted apart from South America and Antarctica. All right. So that's. It's a little bit rounded, but fundamentally that shape is a rifting related feature. South America, the one side is actually a subduction zone; it's collisional. The other side is divergent plate boundary, so it's I wouldn't say that pointed nature of that is due to the same reason as the kind of pointed southern Africa region. There are different tectonic forces at play in those two regions. But southern Africa and southern India, and southern Australia for that matter, are all basically past the margins. They result from spreading of the continents and are largely unmodified since the initial breakup. So the original shape when it broke up is, for the most part, preserved in the modern day shape, at least of the portions of those continents you're referring to. Obviously, northern India was significantly modified by this whole collision. And to get back to our Swiss Alps conversation, northern Africa colliding with southern Europe is what's driving up the Alps. That's part of this whole alpine Himalayan orogeny, which is both Africa colliding with Europe and Southwest Asia, and then India coming up and slamming into the central part of Asia, and even Australia beginning to impinge on the southeast corner of Asia, which over the next 50 to 100 million years will produce another Himalayan scale mountain range.
As a quick follow-up question, you've heard he's trying to get out of the sun here. I apologize. It's a weird...
Oh, you have to apologize for the sun. The sun is good.
Weird angle here. Sorry about that.
It's a bit of... You're better now.
What about her? Sorry. Let me see. Let me put my hand here.
Yeah.
You've heard about the... I'm going to quickly switch topics, but it's related. But getting back to... First of all, you mentioned Pangaea.
Mm-hmm.
And the images that I've seen of Pangaea seems to be that at one point there was a land mass clustered. All of the continents today were actually in one continent, right?
That is Pangaea.
So, and in that sense, I'm thinking that the maps that I have seen, that would suggest that Pangaea took up maybe a quarter to half of or maybe a third of a hemisphere, where the other 2/3 of the hemisphere may have been ocean.
Yeah, and then that ocean is referred to as Panthalassa.
Okay, so maybe could be continents but submerged in Panthalassa.
No, Panthalassa is literally an ocean that covers about 2/3 of the planet, one continuous ocean. If you think the Pacific Ocean is big now,
right.
The Panthalassa Ocean was basically all the modern ocean basins in area,
right,
but combined into a single large ocean. So, I mean, you're on a spherical surface. If all the continents are together in one supercontinent, all the oceans are together in one super ocean.
Is there, where I was trying to draw a leap, and there's probably no connection, but just wondering, this is so weird having a sun like this. Here we go. You've been reading perhaps about the far side of the moon having a different thickness than the near side?
I have not read about that. I think I've seen a headline or something like that, so I can't really comment on that. But yeah, go ahead.
I think part of the Grail mission may be related to looking at gravitational issues and maybe some. Anyway, I was just wondering, just as we had Pangaea on perhaps a third of our planet at one time, where the thick crust existed, And now we're having this issue with the moon where the crust is supposedly thicker on the far side than the near side, I think. I think I said that correct. Is there any correlation or any reason that may be that we've had a clustered continent here where we had a thick landmass, and perhaps the far side of the moon also being thicker?
Well, for the Earth, so let me see. With the moon, so you're dealing with two different things. First of all, the Earth's rotation is such that if you're on the moon, you'll see the entire surface of the Earth over the course of a day, right? As it rotates.
Yes. I'm moving to a better spot. Sorry, go ahead.
No, that's fine. When we view the moon, we're only seeing basically one side of the moon.
Correct.
The dark side of the moon, the far side of the moon is not the dark side so much as the far side of the moon, right?
Right.
The moon is in a kind of, I should be careful with my terminology here because I'm not really sure about this, but yeah, I was going to say tidal lock, but I think that's probably an unsafe.
No, that's correct, tidal lock.
I think basically the moon, you're only seeing the one side toward us, and therefore it's not so surprising that you might in fact have a different composition, thickness, geometry on the near side versus the far side. There's probably a pretty good reason why only one side of the moon faces the Earth and the other side does not. On the other hand, on the Earth, we've had a number of different supercontinents over the course of Earth's history. Pangaea is only the most recent of these. There's another supercontinent about 1 billion years ago called Rodinia. All right, and it's the same continents that we've got in the modern day, but in a different configuration, different from Pangaea. And what's happened is, the continents on Earth, for a time they come together, then they break up and they drift, and then they come together in another configuration. So I would say that, and of course the Earth's tectonics are still very active. The moon, essentially, its tectonics died out 3.5 billion years ago. More than that, probably. Right? But essentially the moon has ceased to be geologically active, at least from a large-scale tectonics perspective. There's obviously weathering on the surface of the moon, so not nearly what you see on the Earth. But, the solar wind does cause some weathering, so I wouldn't say it's completely geologically dead. But, from a plate tectonics sort of perspective, yeah, it has not been active for the better part of 4 billion years. So I would hesitate to draw an analogy between the supercontinents on the Earth and any distribution of crust on the moon too directly, because the rotation of the Earth is such that orientation with respect to the moon means almost nothing. Right. And even when we had the supercontinent on Earth here, it would have rotated, as the Earth rotated, so that it would be at times exposed to the moon side and at times, on the other side.
Probably back, I'm not sure when Pangaea existed, but there was a point in time when the moon was not gravitationally locked, and it would have a spin. But again, maybe not related at all. I just curious about the process that caused the clustering of Pangaea on the Earth, and again, perhaps.
Right, and I would say, so the forces that are moving the continents on Earth today, what's driving plate tectonics, is basically heat loss from the interior of the Earth. That heat loss from the interior of the Earth drives convection in the mantle,
right?
Drives seafloor spreading, drives subduction. That's what moves our modern continents around, and the seafloor along with them. Really, that's what plate tectonics is. Not just happens to be the 100th anniversary of Alfred Wegener's continental drift theory. He viewed the continents as moving separate from the ocean basins, so I want to draw that distinction. I think tomorrow is the actual anniversary of the publication. So, but what's driving this on Earth is fundamentally the heat loss from the interior of the Earth. gravitational tides and stuff. Gravity is certainly part of that convection cell. Yes, it's important. But the moon's gravity and the effect of the moon on Earth tides and stuff is not what's driving modern-day plate tectonics or ancient plate tectonics. The moon's effect on the Earth may have been greater in the Earth's past because it was closer and it's still receding, as we know. And undoubtedly, if you go, I mean, the best modern understanding of how the moon formed was it was a Mars-sized body collided with the proto-Earth, spit off a bunch of the mantle material that eventually coalesced into the moon. Obviously, at some point back there, there is a clear connection, you know, between Earth tectonics and moon tectonics. But most of what's going on in terms of reshuffling of the continents on Earth today, and for the larger portion of geologic history, is the effect that the moon would have on that is a second, third, fourth order sort of effect. Definitely not a first order effect. Probably not even a second order effect. All right, so I think I mean, not to discount the moon's importance for things like, you know, tides. That's clearly a first order effect of the moon's gravitation. But movements, continental drift, plate tectonics, as we refer to it in the modern day, is not driven by moon activities anytime beyond the first couple 100 million years, when obviously the moon was still quite young, and there was that interaction. And you know, we have limited knowledge of that early Earth's history, so you're seeing this in the video, the Nova Origins video, and so that's as good a overview of that time period in the Earth's history as I know of, at least certainly for the public.
What's the leading theory as to why we only had one continent, one Pangaea to begin with?
Well, again, Pangaea was a supercontinent about 250 million years ago, 250 million years ago. The Earth's history is 4.5 billion years. And we've had other supercontinents in the past, and we will in the future, for that matter. All right. There's in the projections into the future, the guys who make these plate reconstructions, in their spare time, they project into the future, and so they envision a Pangaea Ultima, which is the next supercontinent that will occur. It's hard to know exactly what its configuration is, or when it will, you know, come to be. But you know, if you just project modern-day plate motions, certainly Australia is in the progress, you know, with colliding with Southeast Asia. That ultimately is going to reduce the number of continents. And what happens in the Atlantic Ocean is a lot less certain, but past geologic evidence suggests that North and South America will begin to close up the Atlantic Ocean and collide eventually with Europe and Africa again. But again, you know, what that configuration will be. But the point about the Pangaea is, you know, it is for a fleeting time geologically, because it's really only together for 10 million years in its full form. Large portions of it are together for longer spans, but you know, the full-blown Pangaea is probably together for about 10, maybe 20 million years, and then it starts breaking up again. Again, we had another supercontinent back about 1 billion years ago called Rodinia. It also broke up, and presumably there were other supercontinents even before that. We begin to really lack the definitive evidence for them, just because as you go back in geologic time, there's less rocks to preserve the information. The sort of things we use to reconstruct Pangaea are largely the magnetic stripes on the seafloor, while all the oceanic crust is less than 200 million years old. So basically, you know, that'll get us back to about Pangaea. But if you want to go much beyond that, you've got to find other lines of evidence. And there's continental paleomagnetics you can use and that gets you back to Rodinia, or that's the best single line of evidence for Rodinia. There are other lines of evidence as well. I mean, whenever we get a large supercontinent, we tend to have big deserts in the interior of it, and so a lot of these red beds that you see out in the western U.S., well, Triassic red beds, that is Pangaea. That's from the supercontinent of Pangaea. That's why we have so much red rock out on the Colorado Plateau. That was a portion of that supercontinent. And you can go back in geologic time and find other areas where you got this abundance of red rocks that suggests we had a supercontinent. So, I don't know. I guess the point that I would make is just that supercontinents come and go on the Earth as a natural effect of plate tectonic motions. We see evidence for plate tectonic motions that have at least similarities with the with modern style of plate tectonics that go back at least 3 billion years and probably closer to 4 billion years. What exactly plate tectonics looked like in the first billion years of Earth's history, not even that video addresses that very much. And obviously, you go all the way back to the beginning of the formation of the Earth. We have such limited information, it would be very hard to extrapolate that. What we need is a TARDIS.
No, they said at one point the Earth was, 4,000 or 5,000 degrees on the surface?
Yeah.
Back then, it's a little hot for me.
Magma oceans. I mean, magma ocean's hot for anything.
Yeah. So you're saying Red Rocks? You're saying Red Rocks Amphitheater in Denver, which I'm sure you're familiar with from your photographs, and then that goes back to the Triassic period?
Yeah, I believe, in fact, that is... So, the hogback on I-70 right there?
Yeah.
Those rocks are... the rock that's holding up that ridge is Cretaceous. And that's on the Denver side of things. Those rocks are all tilted up against... So let me see if I can get this right. So the Front Range is back over here. These things are all tilted up like this. Right. Younger toward the interior of the basin toward Denver. Older as you go back. Well, what you see in the hogback in the red cup there is basically Cretaceous age rocks, and then a little bit of Morrison Formation, Jurassic age rocks. That's the one with the dinosaur footprints and such. In that, well, actually, some of the dinosaur stuff is in the Cretaceous as well. But below the Jurassic is the Triassic, and that's what you're seeing in the Red Rocks Amphitheater. Yeah, and that is Pangaea time frame. So yeah, that's also Proto-Rocky Mountains. The earlier version of the Rocky Mountains is about that time. I don't know enough detail there, but it's out toward the margins of the Pangaea supercontinent, but it wouldn't be surprising to me if that was in some part associated with the collision of the whole supercontinent. I think the ancestral Rocky Mountains are very much like the modern Rocky Mountains, a little bit hard to explain in normal plate tectonics.
She's telling me she has to go outside here.
That's fine, and I don't want to hold her up.